My name is Lilian and I'm a project manager for Caddick Construction. Passivhaus is a building standard that focuses on creating high energy efficient and comfortable buildings with minimal energy consumption. The concept originated in Germany in the early 90s but gained popularity worldwide, and the primary goal of a passive house is to reduce a building's ecological footprint and energy demand by employing a set of design principles. So passive houses are designed and constructed to be very airtight, and this is to prevent air draft and any uncontrolled air leakage, which will then minimise any need for additional cooling or heating requirements.
My name is Liam Schofield. I'm the airtightness champion on the Burnholme York site working for Caddick Construction. Airtightness is critical. It works in tandem with the insulation of a passive house. So if you make your house super insulated, if air can bypass behind that, then you're still getting the cold air into the house, so the insulation can't do its job properly. So the airtightness works to seal the house, usually in the case of this from the inside, to minimise that air infiltration and to allow the heat recovery ventilation system to work a lot better and to minimise heat loss throughout the house as a whole. So testing and measurements, the main tests that we do on a passive house are leak checking and air tightness testing. So that means that we put a fan into the door, so you suck the air out and then you go around with a small smoke pen and you check every single item around that house. Wherever there's something involving the air tightness, you go and check and make sure that there are no leaks in any of that. So it's common that you get leaks around windows. Even if it looks very well taped, you will find leaks everywhere that you've got a little wrinkle in the tape, so you've got to go along and seal those up.
So the building envelope of a passive house is very well highly insulated, and this is to minimise the heat loss in winter and heat gain in summer. So it's pretty much like a thermos flask concept, which provides a consistent and comfortable indoor temperature.
Thermal comfort is very important in that if you've got a draft in a room, then you have to heat that room much more to compensate for the draft. So you can be in a house that's at a comfortable 21.5 degrees, but you're still not comfortable. You still have to wear a hoodie, you still have to have a little blanket over you, just because you can always feel that draft. In a house such as a passive house where that's been completely eliminated, you can actually sit comfortably in 17 to 18 degrees in shorts and t-shirt because you aren't feeling those drafts.
Number 3 is high-performance windows and doors, which are triply glazed with insulated frames. A fundamental part of the passive house design is to take advantage of the solar gain by strategically placing these windows and openings, optimizing the gain from the winter sun and minimizing the summer sun by utilizing shades like breezeway and blinds. Another design principle is mechanical ventilation with heat recovery system, and this provides a continuous air supply into the indoor environment without constant energy loss.
The MVHR helps to really keep things in control regarding heat loss, so you can keep your house at a very constant temperature. Because it takes the heat out of the outgoing air and puts it into the incoming air, it just maintains the equilibrium of heat, meaning that your heating system isn't having to work as hard. So it works really well with an air source heat pump, which relies on being on all of the time and maintaining a constant temperature to work at its most efficient.
A thermal bridge is basically the element of the building that can transfer heat easily, and this is where the areas that heat loss occurs. So what a passive house design tends to do is to eliminate or minimise these thermal bridges within the building envelope.
The key aspect of airtightness is making sure that it's all linked together. It's quite common for people to sort of put tape or membranes onto a wall and think, well, because I've put the tape onto the wall, that is now completely sealed. It isn't. The critical areas are the junctions between the elements of the property. So you've got to make sure that basically on the drawing, it's done as someone draws a red line onto the drawing and then says, right, that's where the airtightness goes, which is fine in a two-dimensional world. Unfortunately, we live in a 3D reality, and so it's those corners which are the critical areas, and making sure that every tape is overlapped, making sure that every airtight element is attached to another airtight element.
Part as minimising the energy consumption of the building, passive house also includes incorporating a highly energy efficient appliances that helps with the overall energy performance of the building. So whilst the renewable energy is not part of the Passive House certification, the houses at Burnham will have renewable energy sources such as PV panels and air source heat pumps.
So there are a lot of different factors in how energy efficient a passive house is in comparison to standard construction. But with it being super insulated, the airtight envelope, the ventilation system, often you've got solar panels and an air source heat pump running, which just help to minimise those bills and means that you're not governed in quite the same way by the fluctuating energy prices that we've had the last few years.
And by combining all these design elements, Passive House can achieve a remarkable reduction in energy consumption compared to traditional structures. Given that Passive House provides an excellent indoor quality as well as low energy consumption and energy bills, opting for living in a Passive House is really no-brainer. These Passive House schemes are a great way to help City of York Council achieve their environmental targets, and Caddick Construction are proud to be part of it.